Welcome back to STS. In today's video, we're going to find the equation of a tangent line that goes through the point of tangency, which is negative 1, 1, for the function f. Here we see that f is a radical function where we have the cube root of x to the second power. First thing I want to do is to change this from a radical function into an exponential function. So here I'm going to change this into f of x is equal to, we keep the base of x. The index of the radical becomes my denominator, and the power of the variable x becomes my numerator. So x to the 2/3 is the same thing as the cube root of x raised to the second power. From this point, I'm going to now use the power rule to find the derivative. So let's take f prime of x. From the power rule, we know that the current power is brought down to the front as a coefficient, so that there is 2/3. We keep the base of x, and what we end up doing for the derivative is to subtract 1 from that current power. So here currently it's at 2/3, and I need to subtract off 1. Well, to do the subtraction, I need to find a fraction with a common denominator. In this case, it would be 3/3. At this point, when I do my subtraction, I end up with x being raised to the negative 1/3 power. I know that I normally don't want negative exponents, so what I need to do is to move this x from the numerator to the denominator, where that exponent is now going to become positive. So my numerator stays at 2. My denominator is now 3 times x raised to the positive 1/3 power. And the last thing I want to do is to convert this this expression from being exponential back into radical. So my numerator still stays at 2. I keep my 3, and now x to the 1/3 becomes the cube root of x to the first power. Again, the denominator becomes the index of the radical, and the numerator is the power. And again, this 1 here is implied, it's understood. I just put it here explicitly. Next thing I want to do is to take this expression for the slope or the derivative, and I want to input the x value of negative 1 to give me the numerical value for the slope. So let's do that. F prime of 1 is equal to, I keep my numerator at 2, I keep 3, and I'm taking the cube root of negative 1. Actually, I need to put a negative 1 in here because that's my x value. Alright, now I resolve this. I keep the 2 in my numerator, I keep this 3 in my denominator, and that's going to be multiplied. The cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 will give me negative 1. So at this point, I have a negative 2/3, which is the slope for the tangent line. And that slope is, again, known as m, and we can also write out slope. For me to now find the equation for the tangent line, I have the slope, and I have a point, in this case the point of tangency. I'm going to use the point slope formula. With the point slope formula, it is in the form y is equal to y sub 1, y minus y sub 1 is equal to m times x minus x sub 1, where y sub 1 and x sub 1 match the point of tangency. So here, this is x sub 1, and that there's y sub 1. Alright, at this point, I need to do substitutions. Y minus y sub 1, well, y sub 1 is 1, is equal to m. We found m to be a negative 2/3 times the quantity x minus x sub 1. Well, x sub 1 is a negative 1, so that makes this here positive, and I keep the 1. And at this point, I want to change this into slope-intercept form so that I'm able to more easily graph this using a calculator or computer graphing program. So here I see I can add 1 to both sides. All right, in adding 1, these negative 1 and positive 1 cancel out. I'm left with y is equal to, and now I'm going to distribute this negative 2/3 to both of these terms. So I have negative 2/3 x minus 2/3, and I need to add on this 1, but I know that I have a fraction here, so I need to add that 1 on as a fraction. I know that I need a common denominator of 3, so this 1 becomes a 3/3. At this point, I resolve everything to the right of the equal sign, so I have y is equal to negative 2/3 x, and I have a negative 2/3 plus a 3/3. That resolves down to a positive 1/3. So the equation for the tangent line that goes through the point negative 1, 1, negative 1, positive 1 for this function is what we see here. What I'd like to do now is to verify these analytical results with the graphing calculator. So let's move to the calculator, and actually let me just go back to y equals, and we see that I already have the equation in place, and I also have, well, the original function in place, and I also have the equation for the tangent line in place. What I want to do now is let me go back and graph so we can take a look at what that looks like. Alright, I've already zoomed in on the point -1, 1. The blue line is the original function, and the red line is the equation for the tangent line. What I'd like to do now is to use the graphing calculator's tangent function to see what that tangent line, see if that tangent line matches our tangent line that we have here in red. So to do that, we press on second, and then we hit the program button because I want to get to the draw functionality. When the menu comes up, I want to press 5 to get down here to tangent. And then when the tangent window comes up, I want to, or the tangent functionality comes up where it says draw tangent, I want to first change the style. Here I want the style, I don't want it to be blue because that would interfere with the current graph that we have, current function that's graphed. Let's change it to magenta so it's more easily seen. Let's press enter. Let's keep the line as it is, and let's press OK. And we want to draw that point of tangency at the point where x is equal to -1. So I enter that, then I press enter, and we see that the magenta line comes in directly over the red line, which was the equation for the tangent line that we figured out by hand. If you look here at the bottom, we have a decimal equivalent of that particular line or function that we just created. We said that the slope there was a -2/3. We know that 2/3 or -2/3 as a decimal is decimal point 6 repeating. We see that there is accurate up to, what's this, 3, 4, 5, 6, accurate to about 7 decimal points. And we know that 1/3, its decimal equivalent is 0.3 repeating. And again, we see that also being accurate up to about 6 decimal points. Again, the calculator does a type of approximation that has a very slight minimal error. For what we're doing by hand, or for this particular video, that error is negligible. So that sums it up for this video by Speller Tutorial Services. Please visit that YouTube channel, Speller Tutorial, and subscribe. And as always, thank you guys for watching.